Section 2.8, Equations and Inequalities Involving Absolute Value. So first, as a reminder, what does an absolute value mean? Absolute value means distance. And so the absolute value of a real number is the distance from 0 on some number line. And so for this reason, when we're working with absolute value, there's going to be two numbers that will have the same absolute value because they're going to have the same distance from 0, or at some point the same distance from some fixed number on a number line. So for example, if we have the absolute value of x being equal to 5, well, the truth is you're trying to ask what numbers are a distance of 5 from 0. And so, of course, 5 is a distance of 5 from 0, but so is negative 5. Negative 5 is also a distance of 5 from 0. And so with that, the solution set will be negative 5 and 5. And so when we're solving absolute value equations, the first thing that we're always going to need to do is isolate the absolute value part. Get whatever's inside the absolute value all by itself equal to an absolute value. And then, if it's not equal to a positive number, you're going to automatically know that there is no solution because, of course, everything that goes into the absolute value must come out as a positive number. If it is equal to a positive number, then we're just going to set it up to solve. But what happens? Well, you're actually going to end up getting two separate equations. One where the stuff in absolute value is equal to the positive number, and one where the stuff in absolute value is equal to a negative number. And then you're going to solve those two equations independently. So let's find the real solutions of these equations. So first off, we look at our equation. We should isolate our absolute value. Notice that I have absolute value by itself on one side. Then I should check the other side. Well, notice that this is a positive number, and so that's fine. There will be a solution. Well, then this breaks up into two cases. First, the situation where negative 4x is equal to positive 20. That one's fine. And we also have to deal with the situation where negative 4x could have been equal to negative 20. Then we solve each one of these, divide by negative 4, divide by negative 4. X is then going to be equal to negative 5, or divide by negative 4, divide by negative 4. X is equal to positive 5. So we get two solutions. X is equal to negative 5 and positive 5. For our next one, step 1, we need to get the absolute value by itself. So move everything that's not inside the absolute value over. That's then going to be the absolute value of 3 minus 2t is equal to 7. And so now notice we have an absolute value by itself. Well, the absolute value is equal to a positive. Notice that 7 is positive, so this is fine. Then what do? We break it into two cases. 3 minus 2t could equal positive 7. Or 3 minus 2t could equal negative 7. Then we just need to solve for t. So minus 3, negative 2t is equal to positive 4. Divide by negative 2, divide by negative 2. T is equal to negative 2. Or, do the other side, minus 3, negative 2t is then equal to negative 10. Divide by negative 2, divide by negative 2. T is equal to positive 5. So notice that we have two solutions once again. T is going to be equal to either negative 2 or positive 5. Again, minus 7, negative 6/9 times the absolute value of 6x is equal to negative 3. Then I need to get this stuff away from the absolute value, so I'm going to divide by negative 6/9. But division by a fraction becomes multiplication by the reciprocal, so that's the same thing as times negative 9/6, which then I get is the absolute value of 6x is equal to positive 9/2. So now that we have a single absolute value equal to some number, then I have to break it up into two cases. Those are 6x is equal to positive 9/2, or 6x is equal to negative 9/2. Then divide by 6, divide by 6. That gives me that x is equal to 3/4. Divide by 6, divide by 6. This one gives me that x is equal to negative 3/4. So notice that I do get two solutions for this one. X is equal to positive or negative 3/4. Something to keep in mind is that not always will you get the positive and the negative, so don't always assume that. It's possible to get separate numbers. For this next one, notice that step 1, this thing is equal to a single absolute value. So we break it up into our cases. That is going to be x/4 minus 1/3 is equal to 2, or x/4 minus a third is equal to negative 2. Then we solve each of these independently, but notice that because we have fractions, if you would like to clear them via multiplying by the LCD here is 12. That's perfectly fine. And so if I multiply everything by 12, we're going to get that 3x minus 4 is equal to 24. Then add 4, 3x is equal to 28. Divide by 3, x is equal to 28 thirds. We can take the other one and we can multiply it by the LCD of 12 as well. So that's going to give us 3x minus 4 is equal to negative 24. Add 4, get that 3x is equal to negative 20. Divide by 3, x is equal to negative 20 thirds, and so our solutions are x is equal to 28 thirds and negative 20 thirds. I have the absolute value of p minus 5 is equal to negative 8. Notice that the absolute value is isolated, it's by itself. And so when the absolute value is isolated, look at what's on the right side. Notice that here we get negative 8. Well, negative 8 can never be the thing that comes out of an absolute value. Absolute value takes whatever the input is and makes it positive. And so p minus 5 can never equal negative 8. Since this is the case, I can say this is no solution. Or sometimes you may see this written as the empty set. Here I see that the absolute value is not isolated, so I need to divide both sides by 2. Then we get that this is the absolute value of x squared plus 3x minus 2 is equal to 2. So then we need to break it into two cases. That's going to be x squared plus 3x minus 2 is equal to positive 2, or x squared plus 3x minus 2 is equal to negative 2. Then we see that we have quadratics, so we just need to get everything on one side and solve them appropriately. Minus 2, I get that x squared plus 3x minus 4 is equal to 0. Then pick your favorite method of solving a quadratic. If I can factor, I'm going to do so. Looking for two numbers that multiply to give me negative 4, but sum to be positive 3. They are x plus 4, x minus 1. Negative 1 times 4 is negative 4. Negative 1 from 4 is positive 3, and x times x is x squared. There it is. That tells me that x is going to be either negative 4 or positive 1. Now for the other one, add 2. I get that x squared plus 3x minus 2 plus 2 is 0 is equal to 0. I'm going to factor again. I'm going to factor out an x. X times x plus 3 is equal to 0. Then zero product property gives me that x is equal to 0 or negative 3. Thus I get that my solutions are negative 4, 1, 0, negative 3. Remember that in set notation, if you want to put them in order, that's fine. If you don't want to put them in order, that's also fine. Now when solving absolute value inequalities, once again we can think about it in terms of a graph. We'll also approach it algebraically. But if you're thinking about it in terms of a graph, let's consider two functions. F of x is equal to the absolute value of x, and g of x is equal to 4. Here's those two graphs. Notice that f of x is my absolute value function, and notice that g of x equal to 4 is this horizontal line that passes through the y-intercept 4. And so if I were to ask the question, where is the absolute value of x less than 4? Well, notice that that's really this region. This is where the output of the absolute value will be less than 4. And so notice that that's everything on the graph absolute value of x, but below the graph 4. And so specifically, if I'm trying to define that answer, I need to describe it in terms of the x values, and notice that's going to go from negative 4 up to positive 4 for the x values. And if I plugged in from negative 4 to 4 into this absolute value inequality, it will make sense. Plug in negative 3. The absolute value of negative 3 is positive 3. Is 3 less than 4? Yes. 0. Absolute value of 0 is 0. Is that less than 4? Yes. So on and so forth. And so over the interval negative 4 to 4 is the solutions. Now notice that we did not include the endpoints because there is no equality here. Now let's change our question a little bit. So where is the absolute value of x greater than 4? Well, notice that if we're comparing our functions, that's really all of this stuff and all of this stuff. Well, in terms of the x values, where does that happen? Well, that's going to happen for the x values less than -4 and for the x values greater than 4. And so if I plug those x values in, it will make sense here. Let's plug in -5. -5 in absolute value is +5. Notice that +5 is bigger than 4, so that's true. And then you could pick values to the right of 4, 5. Well, that ends up being exactly the same as the last one. And so our solution set will be over the interval between -infinity to -4, not including, once again because of the lack of equality, union 4 not including up to infinity. But we can generalize this algebraically. And so what's going to happen? Well, I'm going to break this up into two categories. The categories where I have the absolute value of stuff less than or equal to some number. And for the record, this is technically going to turn into compound inequalities with an AND statement. Or you can do the other type, which is the absolute value of stuff is greater than or equal to a number, and these are going to be OR statements. And so if I break this up algebraically, the absolute value of some algebraic statement U being less than some number A is the same thing as -A less than U less than A. Similarly, if I have the absolute value of algebraic statement U less than or equal to A, that's going to be -A is less than or equal to U less than or equal to A. And so notice that we're really creating compound inequalities with an AND statement. Now for the next one, these are similar, but they're going to be OR statements. And so when I have the absolute value of some algebraic U greater than A, that's going to give me U is greater than A, or U is less than -A. Now, if you're concerned about what's happening here, I'll tell you that what's really going on is that when we deal with the absolute value stuff, technically what's happening with positives and negatives occurs inside the absolute value. And then if you solve this for U, you're dividing by the negative, and that changes the direction of the inequality over here on the right. With the other one, the absolute value of U being greater than or equal to A, well, that breaks up into U is greater than or equal to A, or U is less than or equal to -A. So just note that when you write the second version of the inequality, it needs to have change direction of the inequality with a negative number. So let's do exactly this. We're going to solve these, and then we're going to graph the solution set after writing the answer in interval notation. So if I have the absolute value of x is greater than 1, step 1 is we need to figure out which one of these it is. Is it an AND statement or an OR statement? Well, absolute value of stuff greater than a number is an OR statement. And so this is going to be x is greater than 1 or x is less than -1. So that's how we do it. Rewrite the same statement without an absolute value, or stuff inside the absolute value, change the direction of the inequality and write a negative on that number. And so now I have my solution set. If I could write that in set builder notation almost instantly, but in interval notation, that's going to be from -infinity up to -1, not including, union, not including 1, up to +infinity. And so if I were to graph this, this is going from -1 and to the left, and going from +1 to the right, where we don't include those endpoints. Now let's do the absolute value of 3x is less than 9. Well, notice that the first thing is absolute value is isolated. Great. Then look at our inequality. The absolute value of stuff less than a number, that's the AND statement. So this is going to be -9 less than 3x less than +9. But just realize that the direction of the inequality dictates what type of compound inequality we have. So when we had absolute value greater than, it was OR. Here, when we have absolute value less than, it's AND. Then we just solve. Divide by 3, divide by 3, divide by 3. -3 is less than x is less than 3. Notice that when I divide by a positive number, no directions of the inequality changes. And so now we just need to write this in interval notation, which is between -3 and 3. And so I can graph this. This is all the values between -3 and 3, not including the endpoints. Same. Step 1, isolate the absolute value. Then notice that this one is already done for us, so I have the absolute value of stuff less than 4. That's an AND statement. AND statement means I can just write it as a single. That's -4 less than or equal to 3t minus 2 less than or equal to +4. Then solve for t, so add 2, add 2, add 2. That is -2 less than or equal to 3t less than or equal to 6. Divide by 3, divide by 3, divide by 3. Negative 2/3 is less than or equal to t is less than or equal to 2. Notice that because of the equality, these will include the endpoints. So in interval notation, this is going to be from negative 2/3 up to 2 inclusive. And then for our graph, this goes from negative 2/3 up to 2 and includes everything in between. Then for our next one, notice that the absolute value is not by itself yet, so I need to isolate the absolute value before I can do anything else. Subtract 3, subtract 3. Absolute value of x plus 4 is greater than or equal to 2. Notice that this absolute value of stuff greater than some number, that's an OR statement. So two situations, x plus 4 greater than or equal to 2, or x plus 4 less than or equal to negative 2. Solve each independently. Minus 4, x is greater than or equal to negative 2, or minus 4, x is less than or equal to negative 6. Now for the interval notation. But side note, if you're having trouble getting from the inequalities to the interval notation, then graph it first. The order in which you do these things, graphing first, interval notation first, it's irrelevant. Whichever one makes the most sense to you first, do that and then get the other. And so for interval notation, this is going to be from negative infinity up to negative 6 inclusive, union, including negative 2 up to infinity. For our graph, remember which one's more negative than the other. So negative 6 is on the left and negative 2 is on the right, because then we have 0 over here somewhere. And then to get from negative 6 and less than that, be a bracket on negative 6 and everything to the left, and then a bracket on negative 2 and everything to the right. Same process. Step 1, isolate the absolute value. So add 7, we get that the absolute value of 1 minus 4x is less than 5. Then notice that this is the absolute value of stuff less than a number. So this is the AND statement. So this is from negative 5 less than 1 minus 4x less than 5. Subtract 1, subtract 1, subtract 1. Negative 6 is less than negative 4x is less than 4. Divide by negative 4, divide by negative 4. Notice that we're dividing by a negative number, which means the directions of my inequalities are going to change. So negative 6 divided by negative 4, that's going to be positive 3/2. And 4 divided by negative 4, that's going to be negative 1. Well, to clean this up, I'm just going to flip it all around, but remember that your inequalities need to point at the same thing they were pointed at before. And so this is negative 1 less than x less than 3/2. Then for my interval notation, this goes from negative 1 up to 3/2, not including. And then for my graph, not including the endpoints and everything in between. The length of a human pregnancy is about 266 days. It can be shown that a mother whose gestation period x satisfies the inequality, absolute value of x minus 266 divided by 16, close absolute value, is greater than 1.96, has an unusual length of pregnancy. Determine the lengths of pregnancy that would be considered unusual. So we just need to solve this absolute value inequality. Notice that this is the absolute value greater than a number. The absolute value is isolated. So then greater is actually going to give us an OR statement. So what is our OR statement? It's going to be x minus 266 divided by 16 is greater than 1.96, or x minus 266 divided by 16 is less than negative 1.96. Solve these independently. Multiply both sides by 16. X minus 266 is greater than 31.36. Then add 266. Add 266. X is then greater than 297.36. Or solve the other side. Multiply both sides by 16. I get that x minus 266 is less than negative 31.36. Then add 266, add 266. We get that x is less than 234.64 days. And so that means that a baby that isn't born before 297.36 days is a little late, and a baby that's born before 234.64 days is a little early.